Okay, it's getting really late, but this last video is for key 1. It is page 372, number 8. The diameter of a car's tire is 52 centimeters. While the car is being driven, the tire picks up a nail. Part A says to draw a graph of the height of the nail above the ground in terms of the distance the car has traveled since the tire picked up the nail. So on the x-axis, we have the ground, so we'll call that 0. Okay, so at the ground is 0, and that's the distance. So that's the height of 0, but it represents the distance coming along here. So this is 0 distance, 0 height. The tire is 52 centimeters, and it's the diameter. So the maximum that tire can go, or the nail can go, is 52 centimeters. So these maximums are 52. We're going to assume that the distance started when the nail got put in the tire. So that happened on the ground here at a minimum at 0, 0. So then as you travel, the nail goes around the wheel over and over again. So this is the graph of that. So looking at that, the diameter is 52, so the maximum is 52. So from 0 to 52 is the height from the minimum all the way to the maximum. Halfway between that will be the axis of the equation of the axis, so y equals 26. If the axis is y equals 26, well then the amplitude is the distance from the axis to the maximum or the axis to the minimum. In either case, the amplitude is 26. So here I have 163.28 centimeters as a distance. So I calculated that by finding what the circumference of one tire is, because the nail starts here and it goes, think about a circle, it goes all the way around the circle. So it's going to go in a full one up and down, it'll be around the entire circle. So from the minimum back to the minimum again, that's the whole circle. So in that, I used C equals 2 pi r. So we're looking at part B here. So I'm going to bring that up, and I calculated that by putting 2 pi and then 26 into the equation. So one revolution is 163.28 centimeters. Part B says, how high above the ground will the nail be after the car has traveled 0.1 kilometers? Well, as you can see here, 0.1 kilometers is actually 10,000 centimeters, and our distance is in centimeters, so I changed it to centimeters. Each revolution is 163.28 centimeters. So I'm going to take the 10,000 centimeters and find out how many revolutions that is. So 10,000 divided by 163.28 for one revolution is equal to 61.2 complete revolutions. So because this is a sinusoidal thing and we keep having the same wave over and over again, we know we have 61 complete waves, and then we start the wave over again at point 2. So what I need to look at is that point 2. If I find out how much point 2 is of 163.28, that will give me the distance here, so 32.7, and then I can go up to the curve to find the height. So we've done 61 waves, and now we are here, and we're going to be at 32.7. So if you recall from the previous page, we had this diagram here, and we figured that one revolution was 163.28 centimeters, and we determined that to figure out how high above the ground the nail will be after it's traveled 0.1 kilometers, we ended up with 32.7 into this curve. So we need to figure out what that is. In order to figure out what the h value is when the distance is 32.7, I need to figure out the equation. So reviewing all of our pieces, we know that the amplitude is 26. We know that the equation of the axis is 26. And we know that the k value is going to be 360 divided by the period. One complete revolution is the period, so 360 divided by 163.28. Now, we've decided to use cos because I'm actually starting at a minimum. I'm not starting at the axis, I'm starting at a minimum. I know cos starts at a maximum, but if I flip it using reflection, I can make it a negative up front. That flips it and makes it a reflection. So we end up starting at a minimum. So that's where that negative came from. Then the A value is 26. I'm using cos because I started at a minimum or a maximum, in this case a minimum. When I did this, I found that it was 2.2 x plus 26. So there was no phase shift because I absolutely did start at a minimum, so I didn't actually shift the curve. This is my equation for this function, and when I want to find out how high the nail was when I traveled 0.1 kilometers, I'm going to plug that into this equation and solve. I'm going to let you do the rest. Good luck, Kiwan. Good luck, everyone. See you tomorrow.